So I think many of you have already done science and tech classes, right? Okay, and it was recently covered. So I think I have already done a lot of current affairs and the things which are in news. But then in this session, we are going to sum up some of the things, and it will be based on the current affair that was there in last 1 year, the important topics, right? First of all, we need to understand, like I told you in the class only, that UPSC doesn't ask any news. They don't ask news. News is a syndicative. So if something is coming as a news information, that won't be asked in UPSC, right? If you look into the question paper of last, 4 years, then you will hardly find anything coming from the news itself, right? So there is something called current that we read, and the current has got context, right? So this is important. This is indicative, and this become important. From there, they basically make question, right? Because questions are not multiple choice, they are multiple query, right? Multiple query, like I told you, that one question, then 3-4 statements, and then you have to pick the right statements from the question, right? So if this is a format, then obviously the current thing which is news or facts, that become less relevant. Rather the context and concept, right? So context and concept, that become important. And if you have done the science and technology classes, then we have already done the entire thing with the respect of current only, right? You get my point? So a lot of thing has been done, but again I'll go with the kind of revision for you people. And obviously we won't have time to discuss a lot of basic thing into it, but then whatever important is there, that we'll try to cover up. One word of caution, that you should cover the entire syllabus, right? Reality is, I'll tell you the reality. The reality is that in UPSC, guesswork doesn't work, right? No teacher in India can tell you that these are the 100 questions you have to cover up and go and write the examination. If could have been so much easy, then obviously it was not UPSC. So guesswork doesn't work. It's just a concept building that we are going to discuss. Okay. So let's take topic by topic. There is one topic that I discussed in our biotech classes that was called non-transgenic GM crop, right? So this is new thing which came up, and obviously this is a news which came up. Like when we were discussing in our class, then I told you that this technology has been developed by Indian Agricultural Research Institute, IARI. So they have developed this technology, and this technology was presented before GEAC, Genetic Engineering Appraisal Committee, to accept it, allow it, so that Indian Agriculture Research Institute can use this technology and develop GM crops, right? And this technology was there with the GEAC since last 4 or 5 years, and GEAC didn't pay any attention to that. Then what happened? There was one news. The news was that France claimed that India has exported 500 metric ton of GM rice. Although we don't grow GM rice, we know that. GM rice we don't grow, but then there are one chance that actually happen at the croplands, that farmers are engaged into this field trial, right? Let's say AIRI or any agricultural research institute or any laboratory or GEAC itself, they involve farmers for field trial. And in the field trial, they provide seeds of the GM crop, which is not yet accepted by, normal cultivation. And then the farmers are basically motivated by the benefits of this GM crop, and they basically change the seed. You got my point? So some seed changing is done, and the farmers start illegally cropping it. So there was a rampant, you can say like news of illegal GM crop being grown in India. Like Gujarat, Haryana, Punjab, Maharashtra. All these states are basically growing good sum of GM crop which are not been accepted still in India. Like HT potato, BT brinjal, GM rice. These are not been accepted, but it is being grown. So that basically that is a lapse, right? Lapse at our own part, lapse at the part of GAC, which is basically the committee which governs the entire issues related to GM crop. And then the France claimed that 500 metric tons of GM rice has been exported by India, and France is close about the GM crop. Rather, we also don't allow GM rice to grow in our crop field. But then it happened. And basically, if such thing happens at international market, then we are going to lose our credibility as an agricultural country or agricultural exporter, right? And then it also shows the weaknesses of the governance and the control of government over the GM crop. Then this news came up. IARI came up with the news, and they basically raised the issue that we are already having something called non-transgenic GM crop technology. And then this GM crop will be accepted by every country that we are basically sending the rice or anything, any grain. Because it will be GM, but it won't be transgenic, non-transgenic GM, right? So that was the news, right? But they won't ask that France was the country or how much metric ton rice has been exported. They won't ask it. Chances are very bleak that they will ask the news factor of this. Rather, they will explore the entire these things, non-transgenic GM crop. And in the last class, we discussed that IARI is basically putting pressure on GAC to accept it. But recently, just few months back, 1 month back, GAC approved it. So that is another news. That is technology which has been applied by IARI to GAC is now being accepted. And now India will grow some GM crop using this non-transgenic GM crop technology. So this is accepted now, right? Accepted. Now, fine. So this news is not important. What exactly this non-transgenic GM crop is? This non-transgenic GM crop, it is based on a technology called SDN. SDN technology. That is called site directed nuclease. This is basically an enzyme, right? Site directed nuclease. Now we have to break this word, non-transgenic GM crop. We know that genetically modified. Genetically modified, that means you make any change in genetics, that is called genetic modification. And genetic modification can be of two types from this point of view. One is called transgenic, where basically you would transfer a gene from unrelated species to a particular species, right? Like we all know BT cotton. So Bacillus thuringiensis gene has been transferred to the cotton plant. That is called transgenic, right? But if you don't transfer any gene, rather you just cut a gene out, then it becomes non-transgenic. You get my point? Cutting a gene out, you just modify the genome by cutting a gene out of the rice, and then just because of removal of a gene, some trait will be, suppressed, some new trait will come up, and then this will be non-transgenic because there is no transfer of gene, but still there is genetic modification. Modification can be of two types. One is additive, you add something, and one is subtractive, where you remove something out. So this is non-transgenic GM crop. And why it has been favored? So first of all, such technology and such approach will require less time, because there you don't need to source a gene and then you cut the gene, paste it over there. There is a lot of technological intervention into it. Rather, just removing one gene by recognizing its potential will be less time consuming, right? So less time consumption. Second, it is equal to natural mutation. natural mutation. So in mutation also such thing happens, like some of the mutation just delete some gene. So it is just a natural mutation kind of thing. It's just like that in laboratory condition we have fastened it. We have basically promoted it. So it is laboratory promoted mutation kind of thing. And if it is natural like mutation, then obviously the European country will not have objection. So it will not have objection, right? So this is how, and obviously the environmental risk is less. Now, how to approach this? I mean, if something comes around this, then how are you going to do it? Simply, we talk about GM crop. Normally, till the time this news came, in our syllabus, we always discuss about transgenic GM crop, right? Although there was cisgenic also, we don't talk about it. But transgenic GM crop we already discussed, right? And then we talk about the issues and concerns of transgenic GM crop. There was environmental issue, health hazard, and other kind of thing. Whenever you have to prove like non-transgenic GM crop and its benefit, I mean, if they frame a question, the question will be exploring this only, that how this is better than transgenic one. So whatever negative point was there in transgenic, that all will become positive over here. Because in transgenic, the biggest problem was with environmental concern, gene escape, we have already talked about, genetic pollution, these all things will not be there because we are not putting any gene into it. Second, consumption of more time in development, in field trial, in acceptance. We all know that it takes 1 to 2 decades to accept any GM crop in India, right? But this will take less time because obviously the environmental concerns are less, the health hazard is less. So it is going to be in a rapid manner. And third, and the most important one, that it is basically very similar to natural mutation. So the country who are basically close for the GM crop, they are close for the transgenic GM crop, they will also accept it because we have not added any gene into it, right? And the latest news about it, that it has been accepted by IARI, and now India will use it to develop the GM crops in coming future. Maybe India must be engaged into the entire experiment and all, right? So these kind of thing that we have to cover up now, because obviously we have talked at a great, you can say like length in our classes. So I'll indicate some topic also. Similarly, we'll discuss one more thing. Like, there is one topic that I feel that it must be there in the examination. Now the thing is that, as a teacher, I do feel that, okay, these are the important topic. But the problem is that UPSC has to ask only 15 questions from science. And many a time it happens that they ask not this year, but next year or next to next year. Even now the current affairs is so widespread that it's not like that 1 year and 1.5 years. You see the mains question they have asked about LED, blue LED. And the blue LED was there in 14-15. So the thing is that current affairs is not like, time bound manner now. It's something which is coming up, right? So I feel that this genomics in India, that will be important because of the COVID, obviously, right? And GIP, Genome India project. And second one is INSA-COG. These are the two things that you must keep in mind. Because genomics in India, in GIP, it's already started in 2020. And we all know that what is genomics, what is genome mapping. It's like you have to read all the genetic data that is written onto the DNA. And once you read it, then you have to find the genes responsible for a particular disease. You need to develop a trend. You need to find that which kind of genetic composition we have. I mean, which kind of disease can affect us more, right? That is the one thing. So in these two topics, if you see, then GIP, Genome India project, is genomics of people living in India. So this GIP is on us. We are the part of the GIP. We are the subject of the GIP. So in this GIP, what India is trying to do? India is basically collecting data from thousands of people from Indian states. And then they are basically analyzing their genetic data. And by putting all the genetic data together, they will create an Indian reference genome, right? Indian reference genome means what? That all possible genes will be there into one reference. Basically, in a very crude term, we can say like we are making a dictionary of genes which is present in Indian population, right? Black eye, blue eye, disease, let's say better immunity, bad immunity, every kind of genes that will be included into that. And then we'll try to understand that how we can help in health sector with the help of this genetic data that we have already collected. How can we find a fight with a disease? How can we develop some medicines that will be useful to counter a particular thing? Like in India, 2-3 things are there. First, the rise of cancer is there in India, right? Oral cancer, mouth cancer, lung cancer. So one of the objective of this GIP is to find out that why Indian population are prone to such kind of cancers, right? And second, India is going to be diabetic capital, you know that. So what kind of genetic basis that we can find out that India is going to be diabetic capital? Obviously, the diabetes has to do a lot with the lifestyle also, but then the genetics will also play important role. So this is GIP, you need to understand it. Second is INSACOG. INSACOG is not about the human genetics, it's about COVID virus genetics, right? So that is how this entire topic is important, because INSACOG is a network of labs to detect new variants of COVID. New variants of COVID virus. So now both private and public labs are included into this network, and whenever we collect any sample anywhere, the test centers, then about 10% of the collected samples are sent to the INSACOG network. Every state has it. And then they basically find out that which kind of genetic variation is present, because we can recognize the new variants of COVID virus by genome, your genetic sequencing, right? By genetic sequencing. And whenever we do genetic sequencing, then it is basically comes under genomics. What we call it? Genomics. So that is how the entire thing is important. But again, GIP is for humans, Indians. Indian genetic reference. Indian genetic reference. And we are in the process of making it. Because we had one reference which came up from the HGP, Human Genome Project. In 2003 we got it. But that reference, that dictionary of the entire genome is not, favoring Indian studies. Because America did it, and America has a more representation of the Western people, and the climatic condition, genetic makeup of the Western people are different from our own, right? So we have to make it India centric, and that is why we came up with the GIP. Now we have technology for that, right? So that is one thing. Besides these two things, because obviously these two things are current affairs which came into the news, there are additional things that India Genomics में कहाँ काम कर रहा है? The two places, health and agriculture. Health and agriculture. Health, I told you, even in agriculture, you have to work with the genomics to develop any new plant variety, right? Like we have done genome project of rice, and we have done it very successfully. And like I told you in the class, we have basically recently we have done with the ragi, we have done with the medicinal plants, right? So these are the area that you need to focus more. Recently there was one more news about the GM crop, that the first GM rubber that was planted in Assam, right? Many people got confused about it. Like I was taking classes in Delhi and they thought that, okay, GM rubber is now accepted in India. It's not like that. It was the first GM rubber plant which has been planted in Assam, right? So it was basically nothing but a field trial. You get my point? It is a field trial only. It means no farmers, no plantations are allowed to use it, right? So the thing is that why this GM rubber has to be developed. You know that rubber is basically a plant which came from the forest of Amazon, right? Hot, humid condition is required for the proper growth of this rubber, right? So rubber is good for the conditions where the climatic condition are hot and humid. But then the northeast are also growing good amount of rubber. You get my point? And Rubber Research Institute is there in the south only, Kerala. So Kerala has developed it. This Rubber Research Institute has developed this GM rubber for northeast. Because in Kerala you get the good environmental condition, hot and humid, that is suited for the rubber plantation. But in northeast there are a phase of winter. And in the winter phase what happens? The growth of the rubber plant, that is stunned. It's not there. So 2-3 months the rubber plant will not grow, especially when the rubber plant is, it's in a, let's say, nascent stage. It's in the developing stage. The small rubber plant will not grow during those 3-4 months. So what they have done, they amplified a gene into the rubber. तो ऐसा नहीं कि ये जीन काट के लगाया. It's not transgenic. It is genetically modified. They have just amplified a gene of the rubber. So in a rubber plant there is one gene and they basically repeated the genes and they made it like 4 genes, right? And by amplifying the gene of a rubber plant, now this rubber is suitable for the cold climatic condition also. So now the northeast and Assam will be able to grow rubber. Rubber plant will grow easily even in the winter condition. That is the only thing, right? So you need to understand it. But then do not get confused. It's not been approved by GAC for the commercial cultivation. That means still in India there is only one crop which is being grown. That is BT cotton. Rest of the things that we talk about, that is under field trial, under experiment, under laboratory trial. So GM rubber, field trial in Assam. Developed by Rubber Research Institute of India, Kerala. And developed long back. It's not like a recent news. They developed it in Kerala. And they basically they wanted to experiment in Kerala itself. But the Kerala government denied it. Because around that time the Kerala was closed about the GM crop. Especially for this kind of GM rubber, right? So they didn't allow it. And it was basically being developed for the northeastern state. So Assam agreed to go with the thing. So that basically become GM rubber. That is the first GM rubber plant in Assam. And that is the only plant. So in the entire world, we have just one GM rubber that is there in Kerala. One more important thing that you need to consider is golden rice. It's been so long that something has been asked around golden rice. And golden rice is important because Philippines became the first country, few months back only, to allow the cultivation of GM golden rice in its state, country. So Philippines have accepted it. Philippines is accepted it. Bangladesh is under field trial. And soon in the coming months, Bangladesh might accept it. And then obviously India will be under pressure to accept it because something will go on. And with the golden rice, there is another topic which become important is food fortification. Food fortification. They won't ask news, right? But you need to understand the concept. There can be two ways to provide the nutrition to the human population. Especially in India, we can talk about. One is GM crop, that you make some GM crop which has properties like golden rice, where you can include vitamin A or some mineral or some nutrient. You can amplify the nutrient amount. That can be done. Another thing, obviously, the golden rice is GM crop. It's a transgenic crop. It will take a lot of time to develop, then to do field trial, then to do experiments, then to analyze the entire result, and then you will have to accept it. So it might take a decade or even 2 decades. Because in golden rice, the project was that by 2005 they will allow. So in a world scenario, the time that has been forecasted, that by 2005, third world countries will accept golden rice and they will start growing it to feed their own population with the vitamin A enriched rice. And now it is 2021 when the first country in the world accepted it. So you can imagine that how long it might take. Food fortification is a intermediate way where basically chemically we enrich something into the food, right? Many people get confused about it. So it's a chemical treatment on a particular grain, on a particular cereals, and then we fortify it with some vitamins, some minerals, and then we use it. So it's safer way, because obviously you don't need to go with it's a kind of adding medicine into it, right? So sometimes you just need to break the rice kernel and then you have to put some medicine or nutrient into it, and then you again, there are technology which can make a rice grain like a structure. And then this grain can be sold into the market. It can be given to the public distribution systems, and there it can be reaching to the people, right? So that is one thing you need to understand it. I'll just indicate it. Now if you move further, so there is one topic which is very important these days, and that is in relation to this COVID only, that is COVID-19 vaccines. Because in the last year they have asked about COVID virus, right? So there was a lot of question regarding virus, because obviously the COVID virus was a new kind of novel COVID coronavirus. Now the entire focus is on how to manage the COVID, right? And in the management of COVID, the most important tool that we have is vaccines. So, this is something which can be indicative that they might ask question from the vaccines and immunity, right? So these things become very important, COVID-19 vaccines and our immunity system. And it's not like that they will ask only COVID related things. The entire vaccination become important. So they can ask anything about the vaccine, right? And obviously, the vaccine basically induce our immunity system to make appropriate antibody to counter with this viruses, right? So, if we talk about the vaccines, so vaccines can be of two types. Broadly, if we classify, first type where we use the whole pathogen or part of pathogen. We all know that vaccine is nothing but the most traditional way of making vaccine, that use the pathogen itself, use the virus itself, right? Sorry. And second one is using genetic material based vaccine. So one approach of the vaccine development is use the same pathogen that you want to fight with. But obviously the pathogen must be killed, must be weakened, must be inactivated, or only a specific part of the pathogen can be taken out, right? Like oral polio vaccine. So oral polio vaccine is a polio virus itself. So basically we give polio virus to the babies, right? But this polio virus is what? It is weakened. It will not create polio, but it is a little bit risky also, I'll tell you about it. Second approach is that you give either DNA or RNA into the body. And we all know that DNA to RNA, RNA to protein. So the body will make protein, which is basically a virus protein, like a spike protein of the COVID-19, you know that. So there are mRNA vaccine, AstraZeneca and all, they have developed it. So this mRNA is what? It's a messenger RNA. The messenger RNA will tell our own cell to produce a spike protein which is being produced by the COVID-19 virus. So COVID-19 virus spike protein will be produced by our own body cells because we have given the messenger RNA. We have given the formula to make it. Messenger RNA is nothing but the formula, the code, the instructions to the ribosome to develop certain kind of protein. So there are two ways. You take the spike protein directly. If you want to take a spike protein directly, you have to go with the whole pathogen or part of pathogen technology, right? And second thing, that you don't want to go with that way, then you can do one thing. You can make a messenger RNA and then you can provide this messenger RNA in our bloodstream so that the cells get instruction to make the spike protein on its own. In both of the conditions, what will happen? The body immunity system will recognize this spike protein and then the antibody will be formed, right? We'll talk one by one. So whole pathogen and part of pathogen. There we have few approach. One is called inactivated vaccine. Inactivated vaccine. So you can say like pathogen is either killed or inactivated. So if it is a virus, it will be killed. If it is if it is a bacteria, it will be killed. And if it is a virus, it will be inactivated in laboratory. And the best example of it is polio and flu. Yes, we'll talk about the COVID separately. But then it has got some issue. It takes long time to develop. And the second issue, you have to culture the pathogen safely, because you have to grow the pathogen itself in the laboratory and then you have to either inactivate it or kill it. So there are some safety concerns regarding it. whole pathogen, the first one is inactivated, right? The second is live attenuated, that is A, B. So you have to go with the live one. Here what we did, we killed or inactivated. Second one is live attenuated. So here what we do, we don't kill it, rather we make it weak. Make the pathogen weak. So it is live only, but weaker. MMR vaccine, mumps, measles and rubella, and your chicken pox vaccine. So mumps, measles and rubella and chicken pox. So here we are not going to kill it, rather we have to make it weak. Again you have to culture the pathogen, that is a problem. And then apart from this, live it might have adverse effect on weak immunity people. Because weakness is a very relative term. You can weaken a particular virus, right? But maybe your immunity system may be even weaker than that, right? So you weaken a virus, but somebody's immunity system can be even weaker than the virus itself. So what will happen now? This vaccine will work as pathogen to that particular person, right? So that is one risk that we have to take it. Third one is viral vector vaccine. So here what we do, let's say if there is one particular dangerous virus which can cause any disease, and we find it very risky to go with live attenuated vaccine, because it might create disease to many people because of the comparative weakness. So we have another way to go with that, viral vector. That means we'll just use a very mild virus and then we'll be putting the part of the pathogen. So part of the pathogen will be included into the mild virus. The mild virus could be adenovirus. Adenovirus is a very milder one. And then in adenovirus, we are going to put some part of the virus that we have to, produce immunity against. And this some part could be protein. So what is done? Pathogen, protein is added with vector virus, which are milder. And then the product that we get it is basically viral vector vaccine. And pathogen, protein. Here you have to understand this is protein. And the Ebola vaccine. Even COVID vaccine are based on that also. But it was Ebola which basically got a lot of So that is viral vector. That means a specific protein included into the virus, and the virus will be introduced in our own body. Virus will act as vector of this protein. There is another one that is called subunit vaccine. Subunit vaccine. This is the most important and not most important, like most popular one. So, use of pathogen protein or sugar directly. So we just use the protein and sugar directly. That means there is no vector required. Here what we used? Vector. Here vector is not used. So we don't need vector. You just need to put the protein inside the body. So many of the vaccines that we have taken in our childhood is basically subunit vaccine only. Whooping cough, tetanus, diphtheria, meningitis, these all are the subunit approach. So these are the 4 types of vaccines where we use either the pathogen or part of it. And this has been there. Now there is something called, second one, genetic vaccine. Genetic vaccine. Or you can also call it nucleic acid vaccine. Genetic vaccine or nucleic acid vaccine. In this, messenger RNA vaccine is very important. So messenger RNA vaccine. And what we do, we just provide the messenger RNA into the body. So messenger RNA in the body. And this messenger RNA is designed to produce protein, and this protein will induce what? Antibody by immunity system. This protein is coming from which? Pathogen protein. So there is a very much similarity between this and this. Here what we do, we directly provide the protein. Here what we are doing, we are not providing protein, rather we are providing the code. So code will be provided to the body. Body has got the protein making mechanism like ribosome and all. And the body will make the protein. Anyway, we have been giving the protein directly, but now we are not giving protein, rather we are giving messenger RNA, and then it is producing protein of the same kind. Antibody will be formed. Now if you come down to the different type of vaccines that we are using in COVID, that we'll also discuss. So, COVID-19 vaccine. There are also 4 approaches have been used. The first is whole virus vaccine. whole virus vaccine. And we know that what exactly it will be. So it will be either live attenuated or inactivated approach. And in India we have Covaxin on that approach only, right? That is why when the Covishield and Covaxin was being compared, then many people basically went with Covaxin. Although it was not a choice basically, एक time पे choice था भी, because people had a faith that this is a technology which is coming from very long time, where the live attenuated or inactivated viruses are being used, and we have developed many such vaccines. So example of this is Covaxin. Then there is called something protein subunit vaccine. Protein subunit vaccine. And we understand what is exactly the protein subunit vaccine. And there is one vaccine we have not developed, Novavax. But then it could not took off because it's too expensive. The expenses of making this vaccine was very high. That is why it is not came into the news. So expensive method. Third is messenger RNA vaccine. So Pfizer and Moderna has developed it. So messenger RNA, same approach, now we understand it. And Pfizer and Moderna, two company who basically get a lot of popularity, and they have developed messenger RNA vaccine. But then the problem with the messenger RNA vaccine, it requires cold temperature for storage. और कितना? तो -70 डिग्री तक. So that's the problem. But then easy to make it cheaper also. So production is easy, production is cheaper, but then storage and operation, that means administration of this vaccine, the procedure become very expensive because of the temperature. Cold chain you have to maintain. From delivery to administration, a cold chain need to be maintained. That is why country like India doesn't go with that. है ना? जैसे हम लोग भी कहते हैं फाइजर का आएगा तो हम लगवा लेंगे, but then it will come with a very high cost if it is coming to India, because maintaining a cold chain in India, it will increase the cost multiple times. And then the fourth vaccine that we have is viral vector vaccine. Our Covishield is that. So Covishield and Sputnik of Russia is basically viral vector vaccine, where the vector is adenovirus. So basically what you do in adenovirus, you put some part of the COVID virus, and then this adenovirus is being administered into the body. So it is easy, effective also. Right. So these are the 4 approach which is being used. So entire vaccination part is important, not the name. I mean, obviously the Covaxin and Covishield, because India has gained a lot of prominence by making 2 leading vaccine in the world, that is called Covaxin and Covishield. And obviously Covishield and Sputnik, they are at the same level, and people understand that Sputnik has got a lot of, efficacy of Sputnik is very high. And similar thing is coming up with the Covishield also. So they can frame a question around the vaccine itself, right? Not necessarily that they will ask the COVID vaccine. UPSC has a very bad habit. The bad habit is that they just look at the news and then they make the question from the background. Directly they won't ask. That is why for a science, for such kind of, objective things, it's become very difficult to, अगर मुझसे कोई कहेगा कि चलो क्रैश कोर्स टाइप से करा दो, तो I'll teach entire science and tech, क्योंकि वो हो ही जाता है. You never know that. Because in science and tech, what is there? Like in the class also, we selected the topic which are important and in news, right? Every topic was in news. Every topic we have discussed was basically linked to the current. So that is basically only current affairs. You get my point? Although the time horizon of our current affairs was not only 1 year. It was 2, 3, 4 years. Otherwise, if you talk about any biotechnology topic, it was only current affair only. Cloning भी पढ़ा तो पता चला कि cloning में भी कुछ चल रहा है. Hisar also came into, Central Buffalo Research Institute, that also come into the cloning procedure, and that is why cloning become important. Surrogacy is important because Surrogacy Regulation Bill, now it is Act, surrogacy become important. DNA Technology Regulation Bill is there, and then discussion is going on in a parliament. That is why this DNA fingerprinting is important. You get my point? So such kind of topics are basically, entire science and tech is important. You cannot differentiate with that. But again, I was told to revise everything. So I thought that why not? Anyway, now like I told you that so if we talk about immunity, human immunity, so we all know that WBCs, and there are 5 types of WBCs. This is basic biology. So neutrophils, basophils, then there is called eosinophils, monocytes, and lymphocytes, right? So these 2 are basically for allergic reaction. Right? Sometimes allergy is there in the body. Sometimes people are basically allergic to dust particles or cold. You will find many people in your circle only who will have running nose all through the year. And if you ask them, then they will say that doctor has told me that I have snowphilia. Right? It is basically eosinophilia, right? People call it snowphilia, snow wala, है ना? उसको गलत pronunciation करते हैं. Eosinophilia means eosinophils number will be very high and there will be running nose, headache, little bit of sore throat all through the time. Neutrophil is basically what? It is involved with phagocytosis. That means cell eating. And which cell eating? Pathogen eating. So they just eat the pathogen. So these two are not very important if they are linked with allergy. So allergy and eosinophil you can match, right? In prelims you do not need to absolutely knowing anything. If you could match it, it's done, right? Like basophil is 0.5%. इसमें तो पूछना भी नहीं चाहिए इसको. Because the entire blood composition of the basophil is 0.5% only. So they won't ask any question about it. Rather eosinophil they can ask it because it is mainly linked with allergic reaction. Neutrophil, the most prominent cells, the most, numerous cells that we have in WBC's category. These are involved with phagocytosis, cell eating. They eat pathogen directly, right? Every time they are working, every time we are getting, some pathogen in our body, and this neutrophil comes up and they eat that, right? And when they eat, what does they do? The lysosome, you know that? So lysosome burst onto this pathogen, and then both WBC and pathogen is killed, right? So this is basically suicide bomber kind of thing, neutrophil. They have a bomb inside that is called lysosome, and they basically allow this pathogen to enter into its own body, in own cell, and then the lysosome will release the enzyme, and this enzyme will kill both pathogen and neutrophil. That's done, right? Monocytes are basically most active phagocytosis cell. They are very active. So if something cannot be dealt with this neutrophil, then the monocyte will come up. They can eat large size pathogen very effectively. The difference between monocyte and neutrophil is normal soldiers, and this monocyte is nothing but the kind of commando. So there is a difference between soldiers and commando. Both are soldiers only, but the commandos are more active. They know how to tackle the greater threats. That is not something. These all four is a part of our innate immunity. That means it's a part of our regular immunity. It's there with everybody. It is a routine immunity. It's like that if something comes, neutrophil go and try to eat that. It won't differentiate with anything. If the COVID is coming, it will try to eat that. If tuberculosis is coming, it will try to eat that. Anything coming, it is try to eat that. It's like BSF, Border Security Force. So BSF people are there on the border, and they have given just one command: secure the border. If anybody is coming from that side, you warn it and kill it, right? Let's say they warn it only, but in a most, let's say if it is North Korea kind of thing, then they won't warn it, they just kill it. तो वहाँ भी तो कोई BSF होगा ही, या Israel. So it doesn't matter who is coming, Russian coming, Pakistan people coming, China coming from the outside and not belonging to India. They don't differentiate, they just kill it. That is called innate. And there is something called lymphocyte, which is there in acquired immunity. Lymphocyte is a specific immunity. This is innate and is non-specific. Innate and non-specific immunity. That means it won't specify its behavior, working pattern according to the pathogen. Rather, they will kill all the pathogen in the same way, right? But then the last one, I write it. The last one was lymphocyte. So lymphocyte, it's a part of a specific immunity. Part of a specific immunity. These are the most important part. And lymphocyte can be of two types. One is called B lymphocyte. Another is called T lymphocyte. And we all know that blood cells are formed in bone marrow. You know that. So whether it is RBC or WBC, it will be formed into the bone marrow. So formation is there in the bone marrow, right? But then once the lymphocyte is formed into the bone marrow, it will go for the training, or let's say maturity. It can go for the maturity at two places. Formed into the bone marrow and stay in the bone marrow itself till the time it gets mature, then it will be known as B lymphocyte. And if it is going to thymus gland, there is thymus gland in our body near heart, and it is going to that particular gland for the maturity, then it is called T lymphocyte, right? So differentiation between B lymphocyte and T lymphocyte at maturity at bone marrow only. Although formation also takes place at bone marrow, that you need to understand. And maturity at thymus gland. That means that take birth in bone marrow and then they get training into the bone marrow, then they become B lymphocyte. If they get training into the thymus gland, they become T lymphocyte. This T lymphocyte, they are the killer cells. Right. They get inside the cell and they kill the pathogen. Right. And this B lymphocyte that produces antibody. And that becomes acquired immunity. So that is why we call it lymphocyte as a very important and the most important part of our immune system, because that is something that is our last resort. Everything fails, then it comes into the play. So if you, obviously immunity system is the entire system, we cannot go into that details at this point of time. But we have different type of barriers in our body. Let's say we have one physical barrier, that is the skin. It's a physical barrier. It doesn't allow anything to go inside. Because the skin first layer has got dead cells, right? And there is a protein called keratin. And this keratin protein make the skin impervious to water and air. Water cannot enter, air cannot enter. And water and air are two major medium through which any pathogen can enter. So we have this physical barrier of a skin, right? And then second, we have chemical barrier. The places where there is no skin, right? In a mouth, there is no skin. There is no let's say a dead layer. In a nose there is no dead layer. In an eye there is no dead layer. All these orifice of the body, all the way into the body, that has chemical barrier, and the chemical barrier is lysozyme enzyme. The enzyme is called lysozyme. Lysozyme. And this enzyme can kill pathogen. Our saliva has got it, our sweat has got it, our tears have it, nose and all other the orifice of the body that secrete some amount of lysozyme. That is why in the majority of time we are not getting infected, because lysozyme is working. So the lysozyme is what? It's a chemical barrier. So physical barrier is skin, and chemical barrier is there in eye, nose, mouth. And these are lysozyme enzyme which kills chemically, right? And there is another chemical barrier. If you eat something, then there is Cl enzyme, HCl acid in a stomach. So HCl, hydrochloric acid in our stomach, that is also basically a chemical barrier which kills the pathogen that we eat along with the food that we have. And it is very obvious that we eat food with pathogen. है ना? Because we live in the ocean of the pathogen, you know that. So in this room, there is everywhere pathogen. So when you open your mouth, it goes inside. But then saliva has got lysozyme, it kills it. If something goes into the stomach, stomach has got SCL, it will kill it. And then if some pathogen can reach to the next level, go into the body, cells, tissues and blood, then what will happen? This WBC come into the play. And WBC will come into the play in three, let's say, layer. First, neutrophil come, and neutrophil will try to eat that. If neutrophil could not handle, then monocytes will come. If the both has failed, then only the lymphocyte will come into the play. And lymphocyte will work in two ways. First, it will produce antibody so that it can kill the pathogen which is moving around. And second, the T cell will go and kill the cells in our body, get inside the cell and will kill it, the pathogen, right? So the most important thing about immunity to produce antibody, right? That is why the entire vaccination comes into the play. In vaccine, we have to put something so that the B lymphocyte can recognize it and produce antibody. Antibodies are very specific to a particular pathogen. One antibody will not work against everything. You get my point? So antibody for COVID, an antibody for flu, other flu, antibody for Ebola, antibody for Nipah, they all will be different. That is why in a childhood we have to administer, a series of vaccines into the baby, right? T lymphocyte, that is very important, and that is one of the reason that with the increasing age our immunity system get compromised. Because what happens, this thymus gland that slowly disappear in the body, right? So if you are around 25 years old, it will be there in the body, and once you cross 25, 30, then the thymus gland is not there. It just vanishes, it does disappear. And if there is no thymus gland, obviously there will be no fresh T lymphocyte. And that is one of the concept of aging, that with the age, the immunity system collapses. It starts collapsing. So let's say if somebody is 40, then obviously they have T lymphocyte a particular amount, but slowly the T lymphocyte will be dying. 65, much of the T lymphocyte has been already dead. 75, more dead. And then in the concept of aging, it is said that the decreasing amount of T lymphocyte will make your immunity weaker, and then the older person will be catching a lot of infection in the later phase of the life if they do not have a healthy lifestyle, right? So this is about the nutshell, information about the immunity system. So and that is why the new variant of this COVID may create a problem, because new variant means new protein, and new protein means that we have to make the new antibody for that. The COVID virus is basically playing hide and seek with us, right? Every time it will come up with the new protein structure, and the new protein structure will be specific to a particular site of the body. Let's say the last one, Omicron, which when it came, then it was said that it was only till throat, upper respiratory tract. Before that Delta, it was basically engaging with the lungs, alveoli of the lungs, the lower part of the lungs, because there the cells are, and the protein which has there onto the COVID, that was complementary to each other. So they were catching like lock and key. So in our body, we have different types of cells. Why we have different types of cells? Because there are different types of protein. And this COVID virus will come up with the new protein. New protein is a kind of key, and we have different locks, right? Each and every cell is having a specific protein. And then if there will be some protein which will match with it, that means this COVID infection will be there on that particular site. So the Delta's protein was matching with the lungs cell. That is why it was engaging with the lung cell, making it worse, and then the people died because of a lot of damage. Omicron was not, mortal. It was not much harmful like the Delta was, because it will engage with the upper respiratory tract only. There was no protein that can engage with the lower part of the lungs, the alveoli of the lungs, right? But then that is why the WHO keep on saying that you never know that which kind of variant will come up and how it will be having its effect onto the body, right? So anything can come up. And one thing is there, we just know those variants which were in news. There was many variants came which were not in news because that variant was not having much pathogenic effect onto our body, right? तो डेल्टा ओमिक्रॉन यही हमने पढ़ा, लेकिन अल्फा बीटा भी आया था, किसी को पता नहीं है, because alpha beta was not much important because it was not having any impact onto the body that can be considered. Anyway, one thing that you need to read it, that is Surrogacy Regulation Act. तो आई थिंक जब हमने पढ़ा था तो एक्ट आ गया था ना, आई थिंक आ ही गया होगा, December 2021 this act came and it got notified. I think our classes was after that only, या उसके पहले हो गया था? हाँ, तो ठीक है. Okay, now we'll move on to the next area. But Surrogacy Act is there, but there is another act that is called ART Act. Right. So people talk about Surrogacy Regulation Act more because surrogacy was very important topic. But again, to make the Surrogacy Act working, they had to pass one more act before Surrogacy Act. Right, so it was like ART Act and then Surrogacy Act. So two acts. Rather you can consider that ART Act become the background of the Surrogacy Act. Because surrogacy is the one type of assisted reproductive technology, we have talked about it. Surrogacy Act is more about controlling surrogacy in India, right? We know that. I mean, banning the commercial surrogacy and allowing only altruistic surrogacy in India, that is Surrogacy Regulation Act. ART Act is basically for donor, recipient and fertility clinic. So donor is sperm donor, egg donor, recipient who can receive it, and then fertility clinic. This all has been managed under a legal ambit under ART. So unless this, because obviously India came up with the Surrogacy Act long back, Surrogacy Bill long back, and they just wanted to regularize surrogacy. But then over the period of time we realized that unless we regularize over here, the full control on surrogacy will not be there. And it's also not wise to have one act and then leaving rest of the things there. So now in this, the major point about the ART Act, that now one female can donate egg in her lifetime just once, right? So one female, one egg. One egg doesn't mean that only one egg. She can give many eggs, but then only one will be used. है ना? एक ही बार use होगा वो किसी भी procedure में. So it doesn't literally mean that one egg she will be giving. She can give 4 or 5 eggs also. But let's say in one procedure 4 or 5 eggs are being given, and then out of 4 or 5 eggs only one can be utilized into any kind of assisted reproductive technology. Rest of the egg will be destroyed. And that is what happened. The regular procedure is that only. So this is the most important aspect, because there also we want to make it, dignified for the female, right? That one female should not be used again and again for the egg retrieval. So that you have to keep in mind. One more topic in biotechnology that I feel is important, but UPSC asked twice in the last 5 years. They have asked 2 questions, that is CRISPR-Cas9, है ना? तो वो मैंने बहुत डिटेल में बताया आप लोगों को. So if anybody is new, then you can just refer to the notes that I have dictated in the class and you will get all the things over there. But again, go prepared with the CRISPR-Cas9, and they might ask some other aspect. Till now, they ask CRISPR-Cas9, the basic concepts of the CRISPR-Cas9, right? And now they can ask about the application aspect also, where it can be applied. After biotech, the most important topic that we think is space. है ना? स्पेस में एक जो मुझे इंपॉर्टेंट लग रहा है अभी, वो NSIL है ना? आपको भी लगता हो, because it's a new commercial wing of ISRO, New Space India Limited, right? Something is new, obviously we have to keep attention on. In UPSC preparation, there is 2 things. One is routine work that you have to do it. Another is your, karma. So UPSC dictates that the karma is that you have to keep eye on everything which is happening. Now it's up to UPSC whether they ask or not. You get my point? So being a teacher, I'll confess honestly that many years I took classes of like 4-hour classes to sum up the entire thing, and many years it happens none of the topic was asked, है ना? ऐसे claim बहुत कम लोग करते हैं, but there was many years where in 4-hour class 3-4 topic came up. समझ में आ रही है? कुछ नहीं कह सकते आप. अब सोचो UPSC के पास कितने ऑप्शन है पूछने के लिए, and they have to ask only 13 to 15 questions. And obviously the intelligence level of the collective intelligence of the UPSC panel and intelligence of a person standing over here, there is no comparison. कोई comparison ही नहीं है. It's just like that in UPSC coaching we have a lot of time. So when you have a lot of time, then we discuss everything possible. And if you have your ambit, if you have your, let's say, area broad, then obviously the question will come up from those areas. But if you try to make a guess out of it, then there we get into the trap. Nothing is like guesswork. Now NSIL, why it is important? So SSLV and PSLV and commercial flight, commercial launches. So in NSIL 3 things are important: SSLV, PSLV, commercial launches, and in all 3 areas, private sector is included. That means we are including the private sector to make SSLV, to make PSLV, and to make and help into the commercial launches. SSLV is 3 stages, all solid launch vehicle. And it can lift 500 kg to 500 km polar orbit and 300 kg to 500 km SSPO, Solar Synchronous Polar Orbit. So these are the 3 things that is there for SSLV, and assembly time is very less. So 7 days it takes all to assemble the SSLV with the least number of manpower. And obviously, if you look carefully, then India launches very small satellites of the entire world, 34, 35 country, and the satellite launches were of those countries are not the big satellites. They are small satellites. You get my point? So we had to make a small satellite launch vehicle which can lift up to 300 to 500 kilogram, least assembly time, least man force, and we can put it into the mass production. So it is in mass production. And whenever you have to do the mass production, you have to engage the external help, right? There are two type of things, research-centric thing, like GSLV is research-centric, still research-centric. So in GSLV, the entire scientific community of the ISRO will work. But when something is already been developed, the technological ceiling has been achieved, then we have to put it into the mass production so that you can fulfill this launching of the commercial launches target. So this SSLV and PSLV is also going under mass production. So I always feel one thing, and that is also important, that different types of rockets of ISRO, that is a very important point where the UPSC can ask question in prelims. They won't ask question from the issues and concern obviously, but rockets of ISRO, whether it is PSLV, SSLV, GSLV, these three things, that is important. So you have to refer into the notes. And NSIL is a wing which is basically taking care of the entire thing. And you remember that Amazonia, Amazonia 1 of Brazil, that was first assignment of NSIL. First assignment of NSIL. So this is one area that you need to understand. Basic concept you have to cover up of the entire space segment. Another area, that topic, if you remember, we had this NISAR. So now the time has come close where we are basically talking a lot about Nisaatnam. NISAR is NASA ISRO synthetic aperture radar. And it will be world's first dual band remote sensing satellite, and most powerful, you can say, like for environmental and ecological studies. So in a nutshell, we can talk in that way. So NASA is giving this dual band SAR. So dual band SAR is being given by NASA, and rest of the thing we are doing it. Launched by ISRO, GSLV will be used. if we talk about, I mean, obviously the Nisar is important. So with Nisar, you have to go into the context, and then there we have to talk about two things: megatropics and the second one is Saral. These two were Indo-French joint mission. These were also remote sensing satellite for environmental studies. So it was a past one, 2011, 2013, long back. But then that is the background. Similarly, there was one telescope that NASA launched, James Webb, right? James Webb तो आप जान ही रहे हो, पढ़ रहे हो आप. But James Webb and its effect on Indian space segment. I mean, from UPSC point of view. So there we have to understand that we have already launched one astronomical satellite long back in 2015 that is called AstroSat. And then we have planned a new one that is called ExpoSat, right? So because of this James Webb and a lot of things which is going around into the space observatory, these AstroSat and ExpoSat, rather ExpoSat is more important. So AstroSat, it's a background, 2015 launch, India's first astronomical satellite. So this is the background, but the important one is ExpoSat. Will be India's second astronomical satellite. It will study celestial events in X-ray. So there is a lots of X-rays which comes in that will catch it, and the payload is Polix, Polix by Raman Research Institute. So India is taking its steps towards it. And there is a lots of concept related to it. I mean, UPSC is one such examination where you have to use the common sense most of the time. There are around 10 questions that will come at the end, है ना? End में वो 45 के बाद का 10 question जो होता है ना, that is decisive. So after 45 you have 10-12 question in your hand where you will be confused that whether what will be the answer, and there you need to apply whatever you have read, whatever you have understood all through. You get my mind? Recently I was in Ladakh. So Ladakh mein jab I teach science, so there is a place in Ladakh that is called Henley, and Henley has got world's highest visible and infrared astronomical unit, observatory है वहाँ पे. That the name of this telescope is called Himalayan Chandra telescope. So obviously I made a point to go there, visit there, because अभी तक पढ़ा रहा था. मैंने कहा कि यहाँ आए हैं तो it's a kind of religious place for me, so I must go. And to my shock, when I went there, then I saw people. I mean, there was a young group from Mumbai, and there is a very nice setup. You can go to the telescope, you can roam inside, you can talk to the operators, and there was one mechanical engineer who basically take care of the entire structure. And the people were like, मुझे कुछ दिखाओ अभी, दिन में ही दिखाओ. So that engineer was having very tough time. He was saying that, sir, there is no live scene kind of thing. This telescope is being operated from Bangalore by satellite. So the people are getting the feed in the Bangalore, not over here. And there is no eyepiece that you can get inside and you can see the celestial event. So I started talking to that person, then obviously I knew a little bit thing, because Henley was in news long back, very long back, 8-9 years back, because this Himalayan Chandra telescope is 2-meter telescope. That aperture size of this telescope is 2 meter only. And then there was a project, international project, where we had to place 30-meter telescope, TMT. And Henley was one of the sites which has been recognized. That 30-meter telescope as an international project, that will be placed into the Henley itself. But then it never happened. Why not? Because India's participation was less into that. So in that way, we need to understand that why this telescope need to be there into the, let's say, space. Why can't we keep it onto the Earth? So there on also in Henley, they demonstrated the entire thing. They have one projection room where they take you and then they project a lot of images which has been shot by and detected by this telescope. And then they tell you that why this place has been chosen. So they say that this Henley is one place which is around 4.5 kilometer above the sea level. Lower atmosphere is 9 kilometer, and it is in the midway of the atmosphere. So in the midway of the atmosphere means what? That there will be very less dust particle. Second thing, that this entire area of that particular region of the Ladakh, around 270 days are sunny days. Sun is there, right? I mean, sunny days means the sky will be clear. Obviously, the astronomical units that is there onto the Ladakh or Nainital, that doesn't work in the daytime. They have to operate in the night time only. But sunny days means the sky will be clear. So 270 days, sky will be clear. That is the one thing. Second thing, there are in the entire Henley, there are around 200 house only. And in 200 house, and then there is a one provision that 11:30 the lights will go off. So 11:30 the government will stop the light supply. दिन में वो सोलर लाइट देते हैं, रात में वो डीसी डिजिटल जनरेटर चलाते हैं, डीजी. And 11:30 there will be total blackout. So there will be no light pollution. And when there is no light pollution, then what will happen? The celestial observation will be clear. So even such kind of information, obviously these are the things that when TMT was part of the syllabus, obviously when India was about to host the TMT onto the Henley, then we had to discuss all the things. And then Henley was not, I mean Henley we have only this 2-meter telescope, 30-meter telescope was basically now being set up somewhere else in a foreign country. So India took the step to launch it, Astrosat and Exposat, into the space itself, so that it can eliminate all the things. In a space there is no humidity, in a space there is no dust particle, in a space there is no protective layer of the earth which can block the gamma radiation or X-ray or any other radiation which is coming from the celestial body. So they won't ask question on the event, what I'm trying to say. Rather they will ask question on an event related to that why these things has been done. What is the benefit of using a telescope or astronomical unit into the space rather than on a ground, and why telescopes are basically placed at the hilltop at the height of 3 or 4 kilometer into the from the sea level. So such kind of questions can come up. Anyway, there is one more thing that we have talked about, and this was very important aspect of Indian space segment, but it failed basically. And if you remember, then we have talked about EOS 03. है ना? Earth Observation Satellite 03. It is a failed mission. Because GSLV failed to deliver satellite. So GSLV, here we won't talk about much about GSLV, rather EOS 03 is important. Earlier it was called GISAT, older concept. GISAT is called Geo Imaging Satellite. So EOS is basically Geo Imaging Satellite, right? This satellite is basically remote sensing satellite. But this is placed in geostationary orbit. So two contrasting things. Remote sensing, that means we have already learned that remote sensing must be placed into the polar orbit or SSPO. But here I am saying that remote sensing satellite GISAT was placed in, it was to be placed in geostationary orbit, 36,000 kilometers away, so that it can focus onto the earth and it can give you real-time image of any part of the India. So it was expected to give 5-minute delay, near real time image of India, of Indian part, you can write Indian parts. So this was one of the dream that we had long back. So 10 years back, we used to teach GISAT in the classroom. But now in new nomenclature, the GISAT is now, it was known as EOS 03. But obviously, the introduction will remain same, geo imaging satellite. And obviously the application of it will be like defense and disaster management, because real time की जरूरत वहीं पे तो ज़्यादा है. So disaster management and defense application, that could have been the application of it. But because we have lost this satellite, and we'll try to get it done one more. You have to pay attention on this particular topic, like Navic. Why? Because it is almost active now, although public integration is not been done. IRNSS. So that is something that you have to read it before you, revise the entire thing, but pay attention to this. And when we are going to talk about this Navic and all, then this Gagan, which is traditional one, that also become important. So entire aspect of it, that why India has to develop this Navic and Gagan, that is linked to something called satellite sovereignty. So we have discussed it in our classes, and we'll have to go with that. Second area that we should focus is the space mission. Gaganyaan is hallmark. So you read that. But when something is very important, very much in news, UPSC try to escape it. है ना? तो लेकिन है भाई कि you have to read it. So Gaganyaan is important, you have to read it. Chandrayaan 3 is important because there we have already planned it that we are sending it, and only lander and rover will be going. So the mission objective that has failed into the Chandrayaan 2 that we are going to achieve it with the Chandrayaan 3. And if you look recently, although the recent news where the ISRO chief has said that we are ready for the Venus mission also, and by 2024 we will be sending Venus mission. Funds and technology and everything is there. So we have already talked about Venusian mission in our class coverage. So obviously, this entire space mission will be something important. Get into that. And not only the factual information about the space mission, rather it will be multi-query question. Then, like I told you, that what kind of benefit the space mission can give us. So that we have to think about it, right? Like study of Venus, and Venus is a twin planet of the Earth. So the study of the Venus will also tell you about the previous structure of the Earth. When the Earth was originated, Earth was formed in the solar system. So that kind of thing that you have to revise it and cover it up. So if you look carefully, then almost everything is there in your notebook itself related to current and all. There is topics that you have to understand it: remote sensing, satellite communication. This is very important. Weather satellite and weather studies, meteorological studies, and there will be two segments of it: satellite and supercomputer. You can also link it with the geography concept, environmental aspect. So these three things, which are basically very application oriented, you have to cover it up. But not by the name of the satellites, rather the function of the satellite. Like remote sensing, what are the functions of it? In satellite communication, what are the functions? And they ask very easy question. This kind of question will not be tough. Like they ask question in the remote sensing that which of the following things can be achieved by remote sensing satellite? And there were 4 options, and you have to choose the correct one. And there was only one incorrect option, that it can manage. It was not about remote sensing ka tha. It can manage traffic. So remote sensing satellite is not meant to manage traffic. It can be done by the navigational satellite, like GPS and Navic. So that you have to eliminate, and rest of the 3 things was correct. So once you go through it, you will be able to know that. Communication satellites are getting prominence these days because India started using extensively into the defense sector, है ना? और बाकी तो है ही इसमें, जैसे इसके फंक्शन में DTH है, VSAT है. So even if you call DTH and VSAT, everything comes under this. But recently what we have seen, GSAT 7 GSAT 7A and recently GSAT 7B. 7B launch नहीं हुआ अभी, but recently, I mean just last month only, Rajnath Singh has made an announcement that GSAT 7B will be the dedicated satellite for Army, isn't it? If you remember. So GSAT 7 was for Navy, GSAT 7 was A was for Air Force, and this is for Army. So it's already been done. This will be in future. So we have talked about GSAT 7 and 7A in our classroom, but 7B was announced recently only, and it was expected to be announced because now this all three armed forces, they need dedicated communication satellite for their uses. So 7 is there with the Navy, and Navy use it for Indian Ocean and the integration in terms of communication with the aircraft carrier, frigates, and the aircrafts that they have in the area of the Indian Ocean. Similarly, Air Force, they also demanding it, and we fulfilled it recently. And now the third step that has been taken and granted by the government, that GSAT 7B will be the third defense communication satellite dedicated to the Navy. So 7 series is like that only, right? So again, I'll tell you that news is not very important, name is not very important, the entire purpose of this is important. And this was long back, we have launched it, 16, 17 something. But then because of this announcement and this launch, this has also become important, right? One more thing, if you read Hindu newspaper and all, then you might have come across, that is space pollution. There was a lot of news about it. Entire one page was there in Hindu, half page. But the thing is that we have already discussed a lot about it, right? And when you talk about space pollution, then from Indian context, you have to understand Mission Shakti. Mission Shakti was what? ASAT missile. Of India. ASL missile testing of India. Because obviously we have created some amount of space pollution by this. And whenever we talk about Mission Shakti and ASAT missile, then it links to something called space defense. So we have to do a lot of integration. And prelims should be like this only. Like when in the class we talk about step by step manner, like this is first part, second part, third part. But whenever you have already completed the entire syllabus, then the things should pop up. Because UPSC prelims will be asking in such manner. 4 options will be there, and they will be converging 2-3 topics into one question. So you must be linking it together, right? Like I told you that weather studies, meteorological studies, satellites and supercomputers. So they must converge at one point. When I'm talking about the space pollution, then China has done it and India has done it. Like if you talk about the Asian country, because India and China is having rivalry in terms of the space technology also. So we have done ASAT and China has done in 2007 itself. The ASAT experiment, anti-satellite missile experiment. So that we have to consider it. And then it basically spark something which is called space defense aspect, right? And with the space defense aspect, it is connected to what? That is called Outer Space Treaty, which is now getting obsolete, like I told you. So now you have any question from biotech or space? Then I can take. मतलब कोई बड़ा टॉपिक मत बताना कि पढ़ाना पड़े, अभी वो टाइम नहीं है, but I can, because it's ocean, right? Being a science and technology teacher is a challenge, because पहले तो करंट सारा पढ़ाओ, फिर करंट दोबारा पढ़ाओ, तो वो नहीं हो पाता. It's already current that you have studied, and all I can do that I can